Hi guys. Welcome back. Today we are going to see the problem minimum absolute difference. In this problem, we are given an array of distinct integers. Our task is to find all pairs of elements such that the absolute difference between the two numbers is minimum compared to every other possible pair in the array. There are a few important rules to keep in mind. Each pair must contain two numbers from the given array. In every pair, the smaller number should come first, meaning a less than b. The difference b minus a must be equal to the minimum absolute difference found in the entire array. Finally, the list of pairs should be returned in ascending order. In short, we are not just finding the minimum difference. We are finding all pairs that achieve that minimum difference. This problem focuses on sorting, understanding absolute differences, efficient comparison of neighboring values. In the next section, we'll go through examples to see how this works step by step. Let's understand the problem better using a few examples. Example 1. Input is array of 4213. First, we sort the array, because the minimum absolute difference will always occur between adjacent elements in a sorted array. After sorting, the array is array of 1 2 3 4. Now, we calculate the difference between consecutive elements. 2 minus 1 is equal to 1. 3 minus 2 is equal to 1. 4 minus 3 is equal to 1. The minimum absolute difference is 1. Now, we collect all pairs that have this difference. A 1, 2, 2, 3, 3, 4. And the output is 2D array of 1 2 2 3 3 4. We'll see example 2. The input is array of 1 3 6 10 15. In this scenario, the array is already sorted. And the differences are 2 3 4 5. The minimum difference here is 2. Only one pair has this difference. 1, 3. 2D array of 1 3. And the last example 3. Input is array of 3 8 minus 10 23 19 minus 4 minus 14 27. First, sort the array. Array of minus 14 minus 10 minus 4 3 8 19 23 27. Now calculate adjacent differences. 4 6 7 5 11 4 4. The minimum absolute difference is 4. Now collect all pairs with difference 4. Minus 14, minus 10, 19, 23, 23, 27. So the output is 2D array of minus 14 minus 10 19 23 23 27. In this solution, the goal is to find all pairs of numbers that have the minimum absolute difference. The first thing we do is sort the input array, because once the array is sorted, the smallest absolute difference will always appear between two adjacent elements. There is no need to compare every possible pair, which would be inefficient. After sorting, we initialize a variable called answer pairs to store the result, and another variable called smallest gap to keep track of the minimum difference we've seen so far. We start smallest gap with a very large value so that any real difference will be smaller than it. Next, we iterate through the array from the first element to the second last element. For each position, we calculate the difference between the current element and the next element, and store it in a variable called current gap. If this current gap is smaller than smallest gap, it means we have found a new minimum difference. In that case, we update smallest gap and reset answer pairs with the new pair, because older pairs are no longer valid. If the current gap is equal to the current smallest gap, then this pair is also valid, so we simply add it to answer pairs. By the time the loop finishes, answer pairs contains all pairs that have the minimum absolute difference, already in ascending order because the array was sorted at the beginning. Finally, we return this result. This approach is efficient and clean, and it avoids unnecessary comparisons by taking advantage of sorting. Now let's run the code with an example. And all test cases executed successfully. Now that we've validated the logic with sample inputs and confirmed the output matches the expected result, we can confidently submit the solution. The approach is optimized, readable, and follows best practices by reducing unnecessary comparisons. This solution is fully accepted and works efficiently even for large inputs. If this explanation helped you understand the problem and solution clearly, make sure to like the video and subscribe for more LeetCode and interview-focused problem breakdowns. I'll be covering optimal approaches, edge cases, and common mistakes so you can confidently crack coding interviews. See you in the next problem.